All right, let's take a look at the decorator design pattern. The decorator design pattern is a structural design pattern that allows you to add or attach new behaviors to objects dynamically without changing their structure, right, or using inheritance. Um, so we're going to look at an example where we try to modify objects, we try to extend objects, and we will use the decorator to add new behavior to these objects, right? The requirements and tools for this lab is we need the Java JDK 1.8 or above, and of course IntelliJ IDEA because it works nicely with Maven. All right, so let's get started. So click on the link below, this link for deliverable submissions, and click on the link for your section to accept the assignment. So accept the assignment. And this should create a repo for you. So reload the page to see the link and then click on the link. Right, so click on the link to open this private repository and then clone this repo. So copy the URL and then go to the terminal and then run git clone, passing the URL to your repo. Right, so this will clone and download the repo into your local disk. So go to the repository, cd there, and now we need to open it in IntelliJ IDEA. Right, so trust the project and this should open it up in IntelliJ IDEA. All right, so I've got this readme file open. Just close these things and let's take a look at the pom.xml. This is the configuration file for Maven, and make sure it's 1.8, and also check that your project is using 1.8. So go to file, project structure, and then change the SDK to 1.8. Right, and if you don't have it, you need to add it similar to previous labs. So this looks good. Let's look at the source code and the test. Right, so source main Java and then the repo, and these are the source files that we will be working on for this lab. Right, so let's go back to the problem statement. So we've got a developer who's working on a comprehensive logging library, which allows writing log messages to multiple storage devices or handlers or transports, right? So console, file, database, syslogs, etc. Log messages can be written in multiple formats, so plain text, JSON, CSV, HTML. So these formats are common in logging libraries like Log4j, for instance. And this library is getting popular, and this developer wants to add more features to it and wants to add new logging device transports with custom formats. So base logger or a console logger with JSON, a console logger with plain text, a file JSON logger, a file colorized logger, a console with YAML format logger, a console with HTML, for example, format, or a file with HTML format logging. So these are combinations of formats for each handlers or transporter, right? So we're going to look at how to add a new responsibility to these objects, the console, the file, the database, without making changes to their underlying classes, right? So the decorator design pattern supports this concept called open-closed principle, which is classes should be open for extension but closed for modification, All right, so let's look at the attempt that this developer was trying to do. So the first one was relying on heavily on inheritance. So as we see, we have classes with file with JSON, console with JSON, file with syslog, file with plain text, and you keep these combination, and it looks really scary. So this is really a class explosion. So without even implementing this, we realize that this is really bad, right? It's really just a nightmare to maintain. You change the base class, you broke all of these combination subclasses, right? And then you get to ask yourself, what happens when login levels like info, log messages, warning, error changes, right? To include debug, fatal, and others. And this will be really complex, right? So the second attempt was basically scaling vertically. So we have one base class, but we put all methods with Boolean return value. So has CSV format, has JSON format, has HTML format, and then we extend this large base class, right? So we get these Booleans. So this is much better, 6 classes in total, but this is really not great, right? So do all these concrete loggers, the file, console, database, HTTP, FTP, need these formatters? No, right? So some loggers, they do not need these formatters. So console, you wouldn't be logging HTML to console, right? Mostly plain text, for example, or other structural formats, right? So adding a new formatter will force us to add new methods and alter the superclass. And again, you change the superclass, you broke these 6 subclasses, right? So this is really bad as well, but not as bad as the first one. So the solution to this is to use the decorator design pattern. So the decorator design patterns will allow us to add new functionality to the base logger without relying on inheritance, right? Or without even changing the base class, as we saw in the second approach, right? So we're going to start with a base logger, right? So if we want to add a formatter for database logger, for example, start with a base logger, and then we extend it with a concrete handler, right? So database logger, console logger, file logger, etc. And then we can decorate it with JSON or YAML or any other format. So we're gonna have a class that's format decorator that will extend the base logger, and then that class has a set of concrete classes: HTML formatter, JSON formatter, YAML formatter, that they will reference the base formatter, passing it to the format decorator, and then adding these functionality to that or these formats to the base logger class. All right, so we're going to look at how to implement this in using the decorator design pattern. Right, so you're gonna have for example, this concrete formatter, CSV formatter, will extend the format decorator and then takes the base logger and then pass it to the format decorator, the superclass, and then adding their own custom logging formats, right? So this will enable us to create different combination of objects with different mix and match without ending up with n subclasses or without adding inappropriate responsibility to concrete implementation, right? So let's look at these 2 questions. We're going to complete the current implementation using the decorator based on the last UML diagram, and then you're asked to explain why is this a better alternative to the previous 2 attempt, right? So this explosion of classes and this vertical increase of really adding more responsibility to the base class and forcing subclasses to inherit something they do not need, right? So let's take a look at how to implement this using the decorator and complete this implementation here, right? So this is the task in hand right now, that we need to take this UML diagram for the decorator and start implementing it, right? So let's take a look at the source code. We are going to be taking a look at the base logger, and remember this is the base logger. So we do need to make this class an abstract class, right? Because there isn't a base logger. It has to be some concrete handler like a console or a file, and then we change the get level to an abstract method, right? So because we want to force subclasses to specify their logging level. Is it an info, warning, error, fatal, etc. Right, so we go to the concrete classes. So the console logger will extend the base logger. All right, and now once we extend it, we have to implement this level. So it's already overridden here. So we go to the database logger. We also extend it. So we extend the base logger in the database logger, and we do the same for the file logger, right? So so we need to be adding, so if we take a look at the UML diagram, this is the base logger, and you get a set of concrete classes, and then we get the format decorator that also extend this base logger, and then you get a set of concrete formatters that they also extend the format decorator, right? So let's take a look at the format decorator. So this is an abstract class that will extend the base logger, and then we will hold a reference to the base logger. And for this method, the get label, we want this to be an abstract, right? So we want to force the concrete formatters to specify the level, right? So let us extend that format decorator here. So this HTML formatter will extend the format decorator. And then we need to add our constructor, taking basically taking a base logger and then setting the base logger in that we inherited from the super class, right? So super.logger equals logger. All right, so this will do our constructor. Next, we need to add the label. So we're gonna say logger dot get label, and then concatenate it with the name of the formatter, right? And then here for the info, we're gonna add the logger dot get level. So we're gonna pass, we're gonna also return the level of this formatter, right? I mean, that's coming from the base class. So we'll do the same for JSON and YAML. So in JSON, we extend the format decorator, and then we will add the constructor, and then we will alter the return value for the two methods, right? So the constructor will take a base logger, and then we set the one in the parent class, super.logger equals logger. and then we go to the get label method, and then we will pass the logger.get label. We'll call it and then invoke that method and concatenate it with a string. Same thing for the level, logger.get level. And then we will do the same for the YAML formatter. So extend that format decorator, add the constructor, and the constructor should take base logger, and then set the one that is defined in the base class, the format decorator. So super dot logger equals logger, and we will alter the return value, so the body of this get label and get level methods, right? So we're going to call logger dot get label. Right, so concatenate that, and then here we will also concatenate the info of the base class, right? So this is looking good for the YAML, JSON, and HTML. One more left is the CSV formatter. So we will need to extend our decorator abstract class, and then add the constructor, and then similarly alter the last two methods, right? So let's do the constructor here. Need to import that one, so you can hit control space, super.logger equals logger, and then we'll alter the body of these two methods, right? Let's grab that label and then concatenate it with our label, right? And then for the level, let's get the concatenate our level with the logging level of the base class, right? So I like to use super.logger, just that will make it more readable, so that way you know that logger is coming from the super class, right? Let me just do the same for the remaining concrete classes, right? This is not required. The code will compile fine, but it will make reading it much easier, because it's coming from the base class, right? So let's do this. I'm just gonna copy and paste. So super dot, right? So let me copy this and then put it in front of the logger, right? So save this for the JSON, and then do the same for HTML. So HTML is there. Just this one for the level, and then the CSV is already there, and that should do it. One more left for the YAML. No. All right, so this is the base logger, and this is the console logger. We extend the base logger. So these are our concrete handlers, right? The devices that our log messages will be logged to. This is the demo class, the main class. So we instantiate a base logger. The concrete type is the file logger, and then we log the level and the label. We do the same here for our console. We can instantiate a console logger, and then we decorate it with a CSV and HTML, right? So we log this, and also we create a file logger, and then we decorate it with JSON, CSV, and YAML formatters. All right, so we basically adding new behaviors to the base logger, file logger, by decorating it with JSON, CSV, and the like. So let's run this guy, run the main class, and see if it compiles and run. Great. So we got a file logger with one level, and then console logger with 3 levels. They're all info, and they're all customized with different formatters. Right. So let's take a look at the test. So this is the unit test that will tell you that the format decorator should be an abstract class, extends the base logger, and has an abstract method called get label. Right. So this is our format decorator. It's an abstract and has an abstract methods get label. So this test should pass. And then we look at the base logger. It should be also an abstract class, has an abstract method called get level. So this is the unit test for the testing the base logger implementation. Yes, it is an abstract class and has an abstract method get level, so that should pass. Let's see what we got here. So abstract, yes, and then here we're testing the concrete handlers. So this is similar to what we called when we used the main method, right? So we check that we have concrete classes, right? So console loggers and then database and file. And here we check the concrete formatters. So we check the concrete handlers. Now we check the concrete formatters. So we check that we have these 1, 2, 3, 4 custom formatters, and we check that we have a method, an abstract method that is overridden by these concrete classes, right? And then here we test the logging with multiple formatters. So we got one console logger, and then we decorate with CSV and HTML formatters, and then we will check the messages for logging the levels. So let's run this test here. And hope for the green check marks. All right, so test passed. That's great. So let's run the test also in Maven. This is what will be executed when you push your code to GitHub. So let's open the Maven tab. Let me expand this. So click on the Maven tab to the right side of this of IntelliJ IDEA. Expand your project, expand life cycles, and then double click on test, or click on test and then click the green play or run button. Right. So this should also pass, but I wanted to check the number of tests passing, making sure that Maven executed them. So that's great. We've got 5 tests that were run, and they all passed. Right. So this is great. So so we did the implementation, and these 5 unit test cases are all passing. And again, you can run it by right-clicking on it or using the Maven test lifecycle, which I always recommend because that's what will be run when you push your code to GitHub, right? So always double-click on this test lifecycle and run it before you push your code to GitHub, right? So let's push our changes to GitHub. So git status. So we modified and changed these files. So we can add them individually, stage them in our local Git repo, or we can push them all by adding their directory or folder, right? So I'm going to be adding git add and then src main. So this added all these files under that directory. So these are staged now, ready to be committed. So let's commit. So git commit -m for the message and done with the, was it 6? Yes. And then we need to push it to GitHub. So git push origin main. So we pushed it, and let's take a look in the build action. So reload, and that should kick in the action for grading, running the test and grading. So click on that, and let's take a look for the auto grading and hope for the green here as well. Right, great, we got green. Now we can look at the auto grading, and then look for the tests, right? So let me scroll down, or you could just search in search logs for the keyword passed. So lab 6 tests passed, all tests passed, and the points you got 100 out of 100. Great, right? And those 5 unit test cases were executed and they passed. All right. So that's how you implement the decorator design pattern and make your changes to this object without modifying them directly, right? So we declared a base logger, and we added a format decorator, and then we implemented the concrete decorators, right? So question 1 done. The second question is is asking you to explain how the decorator design pattern is a better alternative to the previous 2 attempts, right? So in your own words, just explain how is this better than using this explosion of classes, that once you change the base class you broke all these concrete classes, or this vertical scale of a base logger class that has methods that will break in, abstraction, right? So a class that is doing too many things, and concrete classes that are inherited too many methods that they do not need, right? So go to the README file and edit that README file. Just don't change this deadline due date link. Just open up a new or add a new line once you open up that README file, and then you can write in Markdown here. So put a title for Q2 and then put your answer here. All right, and once you do that, make sure you add that, you commit, and you push to GitHub, right? So running get started says you modified the README file. So let's add the file and then commit it, right? I'm not gonna do that. I'm just gonna hit Control C at the end of these commands, but I'm just showing you how to do that, right? So you commit, and once you commit that, you put a message, really any message you want, and then you push to origin main. So pushing that to GitHub, right? So that's it. That's how you do this lab, the decorator design pattern.